Hey guys, today I want to talk to you guys about compound interest. This is going to be like our first kind of application of the exponential function. And we are going to look at problems where we are getting some interest from our bank accounts, right? And it can be compounded in different increments. So maybe your interest is compounded quarterly, maybe it's compounded yearly. Maybe it's compounded twice a year, things like that. So what we're going to do is use this formula over here, our compound interest formula, and this is the amount, the general amount of money that you guys are going to get back. And then the P here is the principal, which I'm going to write little notes underneath these. The principal is what you started with. Notice where it's at in the equation here, right? The principal is in the front. That would be like where our y-intercept is, that we talked about yesterday. The R here is our rate. And typically with the rate, it's a percent. And when we use percents, I don't know if you guys know this or not, but when we use percents in equations, you got to take them out of percent form and turn them into decimal form. So that's going to be something that we have to look at. The N that's used twice here is the number of times compounded. So if it says that it's compounded quarterly, that would be 4, because there's 4 quarters in a year, right? If they say it's compounded yearly, it's just 1. If it's compounded twice a year, that'd be 2. Typically, those are your options. Maybe it could be 8 times a year or something like that, something crazy, but that's where that comes in. And then this T over here is time. Typically, how many years, for example, we have some money into this bank account. Okay, so that's a lot of stuff there. Let's take a look at what that's going to look like for us. All right. So this first example in your book, this girl gets a certificate of deposit when she's born, and it says that it's they deposit $3,000 into this certificate of deposit. It earns 8% interest, and it's compounded quarterly. Cool. So they want to know how much would she have in 5 years. So we are going to go ahead and use our formula and try to figure this thing out. So I know this can look a little intimidating. It's really just one of those things, if you have the formula, you just got to know to plug it in. What to plug in where and use the formula. There are a lot of formulas that look a lot like this, which we'll talk about a little bit more tomorrow too. But in general, I would say that's one of these ones that you're just going to look up what the formula is and then go ahead and use it from there. So our amount, what we're looking for, that's just going to be A. Our principal is our starting point. So they deposited $3,000 to start with. That's going to be our principal. And then this part in here is just going to kind of tell us our constant ratio, right? It's going to tell me the number that we're increasing by or decreasing by with exponential growth or exponential decay. with it's never with interest. It's not going to ever decay, which is nice. They don't take money out of your bank account, even though sometimes it might seem like that. So that's kind of where this plus sign comes in here. So we're always just going to do 1 plus, our rate is 8%. But we have to change it to a decimal. So hopefully you guys all know when you're changing a percent to a decimal, we just divide by 100 or move it back 2 decimal spots. So that's going to be 0.08 for the rate. The n is the number of times it's compounded. That's where this one comes in, compounded quarterly. So since quarterly, that's going to make this a 4. And then on the outside, we already said n was 4. And the time is what we just asked. How much would she have in 5 years? So we're going to plug in that 5 right there. Right? So using the formula, had to grab my calculator, sorry. Using the formula, as long as we know where everything goes, it's not so bad. The part you want to do first is obviously in here. So I'm going to do 0.08 divided by 4 and add 1 to that. And that's going to tell me this rate of increase, right? In this case, it's 1.02. And 4 times 5 is just to the 20th, right? And so that's kind of what this is going to look like when you clean it up a little bit. We figure out what this number is on the inside. We figure out what the exponent it's going to be to is. And then I'm just going to figure out this number. So I'm going to go 1.02 to the 20th power and multiply what I get by 3,000. Notice I don't want to round that number. I don't know if you can. So I just left it on my calculator screen. And then I hit times 3,000. That's what you want to do too. That way you're using all of those digits. You're not just like estimating. That's a bad thing. We don't want to round. So in this case, in 5 years, this CD, this certificate of deposit, is going to be worth $457.84. That's how compound interest works. Yeah, not bad. Just follow the formula. So then the next example question in your book says, how much would she make more if it's compounded yearly? So we're only figuring out the interest once a year, but it's in there for 15 years. So we're getting the same percentage, but what if I compound it yearly instead of quarterly, and we go in 15 years? So let's go ahead and set that one up. So we still don't know our amount. Our principal is still going to be $3,000. That's what we started with. Inside here we got 1. Our rate is still 8%, so we change that to a decimal, 0.08. And the number of times compounded this time, it's compounded yearly, so that's just going to be 1. And then out here, we're just going to have 1 times 15 years this time. So obviously, the more that you compound this interest, the more times that they that means that they're gonna pay you the interest. The more they're going to check your account, check the percentage, and incur that much interest. The more is better, right? We want that to compound as much as possible. So here we're only doing it one time, but we're going 10 extra years. So do I want my money in 5 years? Well, she's a baby. What's she going to do with that money when she's 5? But when she's 15, she's probably going to be looking to buy a car, right? So this is probably a better idea. But let's see what kind of money we're going to get out of here. So 0.08 divided by 1 is just 0.08 plus 1. That's going to give me 1.08. So notice that rate is going to be smaller, but 1 times 15, that's going to be to the 15th power. I'm sorry, our rate's going to be bigger, but our exponent's going to be smaller because the number of times it compounded were only 15 times total. So I'm going to go 1.08 to the 15th. And I'm going to times that number by 3,000. Again, I just left it on my computer screen. And my amount is going to be $9,516.51. And I did have to round up when we're talking about cents here. Obviously, with money, we're only talking about 2 digits, so that's going to be something that you're going to want to do. Cool. That's compound interest. So obviously, that's a much better idea. Obviously, you don't get the amount compounded that you want, but as you wait over 15 years, this is going to give her a pretty good amount of money to buy a car. Yeah, that's about every car I ever bought. That's how much, less than that probably. All right, let's see here. How much time? Yeah, okay. So that was 2 good examples. All of them are going to be kind of set up very similarly, where we are just kind of plugging into our formula, using those numbers. Tomorrow we're going to talk about ones that are not compound interest, but still kind of this story type problem. So hopefully that's helpful, and let me know if you have any questions. Okay?